On October 7th, 2025, a date now etched into the annals of astronomy, the European Space Agency distributed a collection of images that defied immediate explanation. These visuals, capturing the interstellar object designated 3I divided by Atlas, were not merely groundbreaking. They were fundamentally impossible, at least according to the known specifications of the instruments that captured them. The probes in question were designed with a singular purpose, and observing faint, deep space wanderers was not it. Yet the images existed, clear and undeniable. However, the photographs themselves were not the heart of the unfolding puzzle. The profound mystery, the one that triggered a quiet but palpable wave of panic across research institutions worldwide, was what happened the instant these images were released to the public. It was the sudden, synchronized cessation of information from almost every other astronomical source on the planet. Yesterday, the International Asteroid Warning Network announced a collaborative observation campaign scheduled to run from November 27th to January 27th to monitor the object. An enigmatic visitor from interstellar space is presenting the scientific community with a stark and uncomfortable ultimatum. Either we must rewrite fundamental principles of physics, or we are forced to concede that for generations we have been measuring the universe with the wrong parameters. The specific timing of when critical data streams were abruptly halted raises profound questions that even the most hardened skeptics are struggling to dismiss with conventional explanations. If you have ever looked up at the night sky and wondered if humanity is truly alone in the cosmos, what is about to unfold in the next few minutes will illuminate why even the most conservative and cautious researchers are being compelled to reconsider their foundational assumptions about what truly navigates the vast, silent expanse between the stars. It is theorized that we might be observing a technological signature, perhaps a colossal mothership designed to deploy smaller, maneuverable probes into planetary systems. For several months, the James Webb Space Telescope, under NASA's purview, had been meticulously tracking 3I divided by Atlas. It had analyzed the object's spectral signature long before it breached the inner sanctum of our solar system. Then, without warning, the update stopped. The data pipeline froze solid. The official justification provided was a terse and opaque statement, a pause in government operations. Yet this explanation crumbled under the slightest scrutiny. While NASA went dark, the European Space Agency continued to transmit its findings openly. China's deep space instruments, including the Tianwen-1 orbiter, kept recording and sharing their data. Private observatories, from mountaintop facilities to sophisticated amateur setups, never ceased their observations for a moment. Only NASA's channel, arguably the most advanced one, fell silent. We are still, to this day, awaiting NASA's release of the highest resolution imagery of the object, a detailed photograph with a clarity of 30 kilometers per pixel, which was reportedly captured on October 2nd by the High Resolution Imaging Science Experiment, or HiRISE camera, aboard the Mars Reconnaissance Orbiter. Pay close attention to the details that follow. In them, you will come to understand how a calculated absence of information can, in fact, be far more revealing than any formal press conference or official statement. The European Space Agency did not simply publish a few curated photographs. In a move of unprecedented transparency, they opened their entire data archive to the world. They released the raw telemetry, the complex calibration files, and the complete orbital solutions. This allowed anyone with the expertise to see exactly what their instruments saw. Two of their Mars orbiters, the ExoMars Trace Gas Orbiter and the Mars Express, managed to capture 3I divided by Atlas as it crossed their field of view. This was an extraordinary feat, considering these instruments were built to analyze the thin Martian atmosphere, not to photograph faint objects in the blackness of deep space. To achieve this, ESA engineers had to push the hardware far beyond its designed operational limits. They extended exposure times to durations that manufacturers would have deemed reckless, allowing the sensors to detect an object 100,000 times fainter than the sunlit surface of Mars below. What slowly emerged from this painstaking process was an image that challenged established science. It revealed a luminous, incandescent core enveloped in a strange haze. This haze did not scatter light in a manner consistent with reflected solar radiation, which is the expected behavior of a comet's coma. Instead, the object appeared to be self-luminous, generating its own light. One senior ESA mission specialist, in a leaked internal memo, described it as exhibiting light behavior patterns that are inconsistent with all known natural reflection models. Furthermore, the light emanating from it displayed a highly unusual characteristic, a strong negative polarization. Under normal circumstances, light reflecting off a dusty or icy body in space shows a positive polarization. This object did the opposite. NASA's high-resolution orbital camera, HiRISE, could have provided a much finer level of detail, potentially resolving the object's surface features. But the data transmission from that instrument was mysteriously cut off mid-sequence, leaving the world with only ESA's tantalizing but incomplete picture. When astronomers and trajectory analysts began to plot the visitor's approach vector, they were anticipating a degree of chaos. Objects arriving from the void of interstellar space, having drifted for millions or even billions of years, are expected to tumble in at erratic, unpredictable angles. Their paths are warped and twisted by the gravitational influence of countless star systems and galactic forces. They should, by all rights, be disordered. Instead, 3i divided by Atlas arrived with a startling, almost impossible precision. Its trajectory was nearly parallel to the ecliptic plane, the flat, geometric disk upon which all the planets in our solar system orbit the Sunday. Its orbital inclination was measured at a mere 4.89 degrees. The statistical probability of an interstellar object achieving such a precise alignment through natural chance is less than 1%. To be more precise, the odds of this occurring are approximately 1 in 500. Neither of the previous interstellar visitors, Oumuamua or Borisov, exhibited anything close to this level of orbital precision. Buried within the complex trajectory calculations was a sequence of events that, according to probability theory, simply should not emerge from a series of random gravitational interactions. The uncanny alignment with the ecliptic plane was merely the opening act of this cosmic performance. The object's trajectory carried it to within 18.6 million kilometers of Mars at the exact moment when ESA's two orbiters were in the optimal geometric position to achieve a sustained observation. Weeks later, as if following a celestial schedule, the planet Venus was positioned at the ideal angle for Earth-based astronomical instruments to get their best view. Following that, the object's path was perfectly aligned to use Jupiter for a potential gravitational deflection, slingshotting it toward its perihelion, its closest approach to our Sunday. One trajectory analyst at the Jet Propulsion Laboratory, who wished to remain anonymous, described the sequence as surgical timing. For this object to lie so perfectly within the plane of our solar system meant that along its journey, it could orchestrate close encounters with multiple planets. In fact, its path brought it remarkably close to Mars, then Venus, and then Jupiter. The odds of this specific sequence of planetary alignments occurring by pure chance have been calculated to be less than 1 in 10,000. It is analogous to launching a dart from a neighboring galaxy and successfully threading it through a keyhole the size of a dinner plate located in our solar system. The physical characteristics of the object itself defied every established scientific category. Initial estimates of its nucleus size placed it somewhere between 320 meters and 5.6 kilometers in diameter, a range spanning from the size of a large football stadium to that of a small mountain range. Despite actively venting material and releasing a visible trail of dust, a process known as outgassing, it displayed virtually no tumbling or rotation. It also showed none of the slight thrust-induced trajectory shifts that are typical of comets as they are pushed around by these jets of escaping gas. The object's movement was unnervingly stable. Mass calculations, based on its gravitational influence, suggest a minimum weight of 33 billion tons. That is its minimum possible mass. The object must be more massive than that. And yet, despite this immense mass, it exhibited subtle accelerations that its mass distribution and observed outgassing should not permit. What you are about to learn in the next 30 seconds directly contradicts the standard models of comet formation that are taught in every astrophysics program around the world. A detailed polarimetric analysis of the light from 3I divided by Atlas revealed an extreme negative polarization, measuring negative 2.77% at phase angles between 6 and 7 degrees. No catalog comet in history has ever produced a signature like this. This finding implies that the dust or ice grains composing the object have geometries that we have never before encountered in any natural object. It would be like discovering a snowflake that possesses the crystal structure of a diamond, something that might be physically possible in theory, but has never been known to occur naturally in the universe. The object's chemistry only served to deepen the mystery, violating even more scientific convention. Spectroscopic analysis identified abundant amounts of carbon dioxide, CO2, and water ice at a distance of more than 6 astronomical units from the Sunday. This is far beyond the frost line where comets typically begin to activate and release these gases. The ratio of CO2 to water was measured to be 16 times higher than that of any previously studied comet. Furthermore, iron, an element that should be omnipresent in cosmic bodies, was almost entirely absent from its spectral signature. The dust grain behavior it exhibited more closely matched that of a trans-Neptunian object from our own solar system's Kuiper belt, not a traveler from another star system. One frustrated researcher summarized the baffling nature of the object in an internal report. Observationally, it resembles a comet. Dynamically, it behaves like an engineered mass. In this particular case, we observed a composition dominated by carbon dioxide, but we also detected the presence of nickel without the corresponding iron that should accompany it, and also cyanide. These elements are simply not seen in these combinations or quantities in the comets that we are familiar with. As independent research teams from around the globe began processing the open source data released by the European Space Agency, they uncovered an additional correlation that no one had anticipated. When scientists traced the object's entry vector backward, charting its course through interstellar space, one startling detail emerged. Its trajectory originated from a small patch of the sky that was only 9 degrees away from the source of the legendary 1977 WOW signal. In August of 1977, Ohio State University's Big Ear radio telescope detected a powerful narrowband radio burst that lasted for 72 seconds. The signal was so anomalous, so unlike any natural phenomenon, that the astronomer on duty, Jerry Amon, famously annotated the computer printout with a single astonished word, "Wow." On August 15th, 1977, this very famous flare in the radio signal was recorded, and it was given the name the WOW signal because the observers at Ohio State University were stunned at how powerful and structured it was. Upon checking the coordinates, it was confirmed that 3I divided by Atlas came from approximately the same direction in the sky. The original signal had arrived from the constellation Sagittarius at a frequency of 1,420 megahertz. This specific frequency is profoundly significant. It is the natural emission frequency of hydrogen, the most abundant element in the universe, and is often referred to by astronomers as the universal marker for any potential intentional communication. The WOW signal was never detected again, and for nearly 5 decades it remained a complete mystery, an isolated and unexplained event. Now, an interstellar object has entered our solar system from almost the exact same celestial coordinates. Both the Webb telescope and ESA instruments detected subtle energy variations near the 1,420 megahertz frequency emanating from 3i divided by Atlas. These were not clear, structured transmissions, but rather faint fluctuations. Were they a coincidence or some form of cosmic echo? This convergence of anomalies led the renowned Harvard astrophysicist Avi Loeb to propose a radical shift in our framework for seeking extraterrestrial intelligence. What if, he argued, interstellar messages do not arrive in the form of electromagnetic signals or coded mathematical sequences? What if they arrive as physical objects, objects whose very trajectories, precise timing, and anomalous physical properties constitute the message itself? If 3i divided by Atlas represents such a form of communication, then its impossible precision and its bizarre behavior would be the syntax and grammar of an alien language. Most observers will likely miss the implication of what I am about to reveal next. But if you have followed the evidence this far, you are about to understand why all conventional explanations for this object continue to fail. A compelling competing hypothesis began to gain traction within the scientific community: the theory of panspermia. This is the idea that life spreads throughout the universe through natural distribution, with fragments of ice and dust carrying dormant microorganisms or the essential prebiotic chemical building blocks between stellar systems. A detailed analysis of 3i divided by Atlas's spectrum revealed the presence of significant organic carbon, methane, and complex hydrocarbons. These are molecules that would require millions of years of exposure to cosmic rays to synthesize naturally. This suggests that the object has likely traveled for eons, perfectly preserving its complex chemical layers like a cryogenic archive hurtling through space. Furthermore, its outgassing was not chaotic and random, as one would expect from a simple comet. Instead, it was rhythmic, dispersing its carbon-rich particles in remarkably balanced and controlled distributions. Computer simulations later confirmed that such a process could effectively transport microscopic material across the vast distances between stars, which is precisely the behavior one would require from a biological seed object. A reconstruction of its trajectory even suggests that 3i divided by Atlas may have originated from the habitable zone of the Kepler 442 system, a distant star system known to contain promising Earth analog candidate planets. The encounter with Mars was historically unprecedented. It marked the very first time in human history that our instruments orbiting another planet were able to record an interstellar visitor at close range. The ExoMars orbiter painstakingly stacked multiple long exposure frames to accumulate enough signal to form a clear image. Each successive frame revealed a pale, distinct nucleus trailing faint streams of ejecta. The Mars Express orbiter corroborated these findings independently. But the combined data revealed something even more extraordinary. The object was pulsing, not randomly venting gas. It was a singular, historic convergence, a traveler from far beyond our own star, and the human technology capable of observing it, intersecting at a moment of perfect, preordained geometry. The discovery made in the next 25 seconds of observation will permanently alter how you interpret every future announcement about comets and asteroids from any space agency, a pattern began to materialize in the data that resisted every conventional interpretation. The brightness of the object was observed to be fluctuating in a precise, unwavering 11-hour cycle. The regularity was as exact as a mechanical oscillation. The James Webb Space Telescope recorded light curves that repeated with the steady rhythm of a cardiac monitor. This suggested either a degree of rotational stability that is unheard of in a natural body of its size and mass, or, more provocatively, that there were internal processes at work emitting energy in perfectly synchronized intervals. From the other side of the world, Chile's Atacama Large Millimeter Divided by Submillimeter Array, an interferometric telescope, confirmed the identical 11-hour periodicity. The signal was not stochastic, it was not disordered. It appeared, for all intents and purposes, to be deliberate. This single discovery catalyzed a level of international scientific collaboration that was unprecedented in its scope. China's Tianwen-1 orbiter verified the pulse emissions from its own unique vantage point. The United Arab Emirates' HOPE probe contributed crucial infrared spectral data, adding another layer to the analysis. Throughout this period, the European Space Agency maintained its policy of total open access to all telemetry, issuing a global invitation for analysis. For the first time, research into an interstellar object transcended geopolitical boundaries and rivalries. Hundreds of amateur astronomy facilities contributed their own tracking data, which was then cross-referenced with the findings from major institutions like Harvard, Caltech, and the European Southern Observatory. Right now, before we proceed any further, it is crucial to understand that there is something hidden within the spectral data that fundamentally changes how we must interpret everything that came before. NASA's communications blackout was not, as it turned out, absolute. A series of preliminary reports were quietly released, indicating that the James Webb Space Telescope's spectral readings of the object contained frequency distributions that were not readily explainable through known natural cometary processes. The agency formally acknowledged the existence of the Webb's light curve data, but provided only a minimal interpretation of its significance. In their brief statement, scientists noted the presence of energy signatures differing from typical cometary behavior. This announcement marked the first substantive acknowledgement of the object's anomalous nature from NASA, since their data flow had mysteriously decreased, though it ultimately raised far more questions than it answered. In response, Avi Loeb publicly called for the formation of an international committee dedicated to the study of interstellar objects, arguing passionately that transparency is the only path to revealing the truth, while institutional restriction and data management only serve to breed suspicion and uncertainty. The public discourse surrounding 3I divided by Atlas had transformed. It was no longer just about a strange rock from another star, but had become a symbol of the global debate between open scientific inquiry and classified institutional control. Then, the European Space Agency documented one final baffling observation. In the last set of images captured before the object moved out of range, its coma, the cloud of gas and dust surrounding the nucleus, expanded dramatically. As it did so, it formed a distinct spiral geometry, a shape that has never been cataloged in the observation of any natural comet in history. A final spectral analysis of this new formation showed recurring energy concentrations precisely at the hydrogen line frequency of 1,420 megahertz. Embedded deep within the Mars Express telemetry from this final observation, technicians discovered a faint, anomalous signal. It was a signal with characteristics that appeared to originate not from the object itself, but from the direction of Earth. It was not classified as instrument interference, nor was it a calibration artifact. It was a distinct phenomenon that demanded an explanation. This final inexplicable data point is precisely why a scientific consensus on the nature of 3 I divided by Atlas remains elusive to this day. We are left with a cascade of irreconcilable facts. The object arrived from celestial coordinates that are suspiciously close to the source of an unexplained intelligent signal from our past. It moved with a mechanical precision that seems to defy statistical probability, and it exhibited a chemical composition that blurs the very distinction between natural cosmic debris and purposeful engineered architecture. In the face of this profound mystery, the European Space Agency provided complete and transparent data access to the global community. In stark contrast, NASA's information flow decreased abruptly and without any detailed public explanation. One agency opened its entire archive for scrutiny, while the other restricted access to its most critical data. Whether 3 I divided by Atlas was a cosmic statistical outlier of astronomical proportions, or a deliberate construct traversing the immense distances between the stars, it forced humanity to confront a deeply uncomfortable question. Are we merely passive observers of the universe? Or does the act of observation, in fact, flow in both directions? If this object represents just one traveler, how many countless others are drifting undetected in the infinite darkness between the stars? And when the next one inevitably arrives, will we have learned enough to recognize the pattern for what it is? Or will we once again categorize it as just another anomaly and simply move on? The answer to these questions may already exist, buried within the megabytes of data we have already collected. We simply need to develop the courage to recognize that what once appeared to be impossible has now become undeniably real.